Okie dokie. So today we're going to go ahead and talk about free fall. So we know that free fall is the motion of like an object when it's only under the influence of gravity. And that is assuming there's absolutely no air resistance for something to truly be in free fall. The acceleration due to gravity, we'll use the little symbol g for that. So it's going to be a little g. By definition, g is always positive. So always positive by definition. On Earth, we'll say g is approximately 10 meters per second squared. And then on Earth, it's exactly 9.8 meters per second squared, or it'll be more, a couple more digits after that. I pretty much only use 10 meters per second squared in problems, just because it's easier for quick math and rounding. You can ultimately use whichever one you want, and you'll totally be correct. A couple other places just for fun. Moon, we know g is about 1.6 meters per second squared, while the sun, that is a massive planet. It's not a planet, excuse me. G is 270 meters per second squared. Massive sun. Cool. So let's go ahead and talk about a quick little example. So let's say I have a tennis ball, or any type of object, and I throw it upwards at time t equals 0 with a velocity of 30 meters per second. Okay? I'll draw a little bigger arrow to say that's a pretty big velocity. 1 second later, t equals 1 second. Let's think about what its velocity is going to be. So we know that the acceleration due to gravity is 10 meters per second squared. And I'm going to say for this problem that the upwards direction is positive. So if the upwards direction is positive, the acceleration due to gravity is pointing downwards. So it's going to be negative g, or negative 10 meters per second squared, just because we define down as the negative direction. So this means that your velocity changes by negative 10 meters per second every second. So, okay, we're at 30 meters per second. Now we're going to go to 20 meters per second. Okay, so now let's look at t equals 2 seconds. Let's see, the velocity is going to be 10 meters per second less than that, 10 meters per second. Now let's go to one more point. So we're still going up there. At t equals 3 seconds, so we have to decrease 10 meters per second from where we are. So we're just going to be left at 0 meters per second. Cool. So we have reached our highest point right there. If it's going 0 meters per second, it can't go up anymore. So this right here is the turning point. Cool. Now let's look at the way down. So at t equals 4 seconds, and again, the acceleration is negative 10 meters per second, so it has to decrease 10 from 0. So we're going to be left with negative 10 meters per second. So it's the same velocity as the other side, or same speed as the other side, with just the opposite sign. Now let's look one more second. T equals 5 seconds, our velocity is going to be negative 20 meters per second. Now one more second, we'll decrease our velocity 10 meters per second more, and so we'll be at negative 30 meters per second. Perfect. I'll go ahead and outline this as a little beautiful parabola. Cool, physics is so beautiful. One thing I like to look at is my signs. I know we've chatted about it before. So, okay, here my velocity is positive because I'm going upwards in a positive direction. We defined upwards as positive. My acceleration, gravity pushes things down. My acceleration is downwards, or a negative direction. Whenever my velocity and acceleration have opposite signs, I am slowing down. Cool. And I know that if something's going upwards, slowing down, like you try to jump off the ground, you're going to slow down real quick. You're not going to get very far, unless you're like Michael Jordan or something like that. Let's look at the other side. So on this part, where velocity is going downwards, my acceleration is also pointing downwards, going in the negative direction. Gravity pushes things down. Both those signs are negative. They're both the same signs. So we are speeding up. Awesome. So now what we're going to go ahead and do, actually we'll just leave it like that. And then I'll have another video where we'll go through a practice problem.